907, clear takeoff 07 right.
Clear takeoff runway 07 right, Singapore is 61.
Welcome back to the Canadian Aviator. In this 8th episode, airplane V speeds. Whether you are an aviation enthusiast, pursuing your Canadian commercial pilot license, or preparing for a written or practical exam, this video is made for you. Stick around until the end, where I'll be sharing exam-style questions you are likely to see in real test. One of the most common questions from people who aren't familiar with the aviation industry is, how fast does the airplane go? Well, in this episode, we are going to break down 26 different speeds associated with an aircraft, and you will quickly discover that this simple question actually needs a bit more specification. Let's start with V1, or Critical Engine Failure Recognition Speed. V1 is a takeoff decision speed used only in multi-engine aircraft. On the airspeed indicator is identified by a blue line. It is defined as the critical engine failure recognition speed. This means that V1 is the maximum speed during the takeoff roll at which a pilot can recognize an engine failure and still safely stop the aircraft within the remaining runway. However, once the aircraft passes V1, the takeoff must continue, even if an engine fails, because there is no longer enough runway remaining to stop safely. V2 – Takeoff Safety Speed. V2 is known as the takeoff safety speed and is used in multi-engine aircraft. It is the minimum speed that must be reached and maintained after takeoff if one engine fails. At V2, the aircraft is able to climb safely with the critical engine inoperative while maintaining adequate control and performance. V2 is not a standard market speed on a traditional analog airspeed indicator due to the fact that it varies according to aircraft weight and environmental conditions. It has to be calculated before each takeoff. V2 minimum. V2 minimum or minimum takeoff safety speed is the lowest speed that must be achieved and maintained after liftoff in a multi-engine aircraft if the critical engine fails at V1. V2 minimum ensures the aircraft can safely climb with one engine inoperative, and at this speed, the aircraft provides adequate controllability, sufficient climb performance, and a safe margin above stall speed. It also guarantees compliance with required obstacle clearance and climb gradient regulations. Flying below V2 minimum during an engine failure could compromise climb performance and aircraft control. V3 – Flap Retraction Speed. V3 is the flap retraction speed used after takeoff. Once the aircraft reaches a safe altitude and accelerates beyond V2, it continues accelerating to V3. At this speed, the flight crew begins retracting the flaps. V3 provides a safe margin above stall speed, ensuring the aircraft maintains adequate lift and control while flap configuration is reduced. Respecting V3 ensures a smooth and safe transition from takeoff configuration to clean climb. VA, or Design Safety Speed. VA, or Design Safety Speed, is the maximum speed at which full and abrupt control inputs can be made without overstressing the aircraft structure. Below VA, the wing will stall before structural damage occurs. Above VA, aggressive control movement could exceed structural limits. On the airspeed indicator, VA is not usually marked with a colored arc. It is typically published in the aircraft operating handbook and may be displayed as a reference speed depending on the aircraft type. VB, speed for maximum gust intensity. VB is the speed for maximum gust intensity. It is the maximum speed at which the aircraft can encounter strong vertical gusts without exceeding structural load limits. At or below VB, the aircraft can better absorb sudden gust loads because the wing will tend to stall before structural damage occurs. Flying above VB in turbulent conditions increases the risk of overstressing the aircraft. VB is not normally marked on the airspeed indicator and is found in the aircraft performance or operating handbook. VC, design cruise speed. VC or design cruise speed is the maximum speed at which the aircraft is designed to operate in normal cruise conditions. It represents the highest speed that can be flown in smooth air without exceeding structural design limits. However, it does not provide protection against strong gusts or turbulence. VC is not usually marked on the airspeed indicator and is published in the aircraft's flight manual as a structural design limitation. VD, design diving speed. VD or design diving speed is the maximum speed considered during the aircraft's structural design and testing. It represents the highest speed the aircraft is built to withstand during certification flight testing, typically in a controlled dive. VD provides a safety margin above the maximum operating limit speed. VD is not shown on the airspeed indicator. Instead, the red line on the indicator represents VNE, which is set below VD to ensure structural protection in normal operations. VDF, MDF, demonstrated flight diving speed. VDF or MDF in Mach number is the demonstrated flight diving speed achieved during certification flight testing. It is the highest speed actually reached in flight tests to demonstrate the aircraft's structural integrity and stability in a dive. VDF or MDF must be lower than the design diving speed, VD, providing a safety margin. This speed is not shown on the airspeed indicator. Operational limits are indicated instead by the VNE or MMO, which are set below the demonstrated dive speed for normal operations. VF, flap operating speed. On the airspeed indicator, VF is typically marked by the upper end of the white arc, indicating the safe flap operating range. VF is the maximum speed at which the aircraft's flaps can be safely extended or retracted. Flying above VF with flaps deployed can overstress the flap system or cause structural damage. The speed varies depending on flap setting and aircraft type. VFE, maximum flap extended speed. VFE is the maximum speed at which the aircraft can fly with flaps fully extended. Exceeding VFE can overstress the flap system or cause structural damage. Each flap setting has a corresponding VFE, which is published in the aircraft flight manual. On the airspeed indicator, VFE is usually indicated by the top of the white arc, marking the safe speed range for flap extension. VH, maximum level fly speed. VH is the maximum speed the aircraft can achieve in level flight using maximum continuous power. It represents the highest true airspeed attainable without descending and without exceeding approved engine power limits. VH is determined during aircraft certification under standard atmospheric conditions. VLE, landing gear extended speed. VLE is the maximum speed at which the aircraft can safely fly with landing gear extended. Flying above VLE with the gear down can cause structural damage to the landing gear or its supporting structure due to excessive aerodynamic loads. VLE is published in the aircraft's flight manual and may be shown on the airspeed indicator as a limitation depending on the aircraft type. VLO – Maximum Landing Gear Operating Speed. VLO is the maximum speed at which the landing gear can be safely extended or retracted. Operating the landing gear above VLO can cause structural damage to the gear doors, actuating system, or supporting structure due to excessive aerodynamic forces. VLO is published in the aircraft's flight manual. In some aircraft it might be indicated on the airspeed indicator as a limitation, but it is primarily referenced from performance data and operating procedures. VMC – Minimum Control Speed. VMC is the minimum control speed with the critical engine inoperative in a multi-engine aircraft. It is the lowest speed at which the aircraft can maintain directional control using maximum rudder input and no more than 5 degrees of bank towards the operating engine. Below VMC, the rudder will not produce enough force to counteract asymmetric thrust, and the aircraft may yaw or roll uncontrollably towards the failed engine. VMC is marked on the airspeed indicator with a red dial line. VMO, MMO, or Maximum Operating Limit Speed. It's the highest speed an aircraft is allowed to fly under normal operations. VMO refers to the maximum speed in knots used at lower altitudes, while MMO refers to the maximum Mach number used at higher altitudes where air density decreases. These limits are set by the aircraft manufacturer to prevent structural damage, excessive aerodynamic loads, or loss of control. Exceeding VMO, MMO can compromise the aircraft's safety, so pilots carefully monitor airspeed to stay within these certified limits. On a traditional analog round dial airspeed indicator, VMO is marked with a red dial line on the outer edge of the gauge. VMU – Minimum Unstick Speed. It's the lowest speed at which an aircraft can safely lift off the runway during takeoff. It is determined during certification testing and represents the minimum speed at which the aircraft can become airborne with the correct pitch attitude and maximum takeoff thrust. Below VMU, there is not enough aerodynamic lift to leave the ground safely. VMU is used by manufacturers to help calculate takeoff reference speed, like V1 and VR, but it is not normally displayed to pilots on the airspeed indicator. VNO – Maximum Structural Cruising Speed. It's the highest speed at which an aircraft can be safely flown in smooth air. It marks the upper limit of the normal operating range. Above VNO, the aircraft may be exposed to structural stress if it encounters turbulence or abrupt control inputs. On an analog airspeed indicator, VNO is shown as the top of the green arc. VNE – Never Exceed Speed. It's the absolute maximum speed an aircraft must never exceed under any circumstances. Flying beyond VNE can cause structural failure, flutter, or loss of control due to excessive aerodynamic loads. On an analog airspeed indicator, VNE is marked by a red dial line and the needle must never go beyond this limit. VR – Rotation Speed. It's the speed during takeoff at which the pilot begins to lift the aircraft's nose to initiate liftoff. At VR, there is sufficient airflow over the wings to safely increase pitch and allow the aircraft to become airborne shortly after. VR is calculated based on weight, runway conditions, and aircraft configuration. It is not marked on the airspeed indicator. Instead, pilots reference it from the takeoff performance data for each departure. VREF, landing reference speed. It's the target speed flown on final approach during landing. It provides a safe margin above stall speed while allowing the aircraft to touch down at the correct speed and distance. VREF is calculated based on aircraft weight, configuration, usually full landing flaps, and sometimes wind corrections. It is not permanently marked on the airspeed indicator. Instead, pilots compute or obtain from performance data before landing. VSL, minimum steady flight speed obtained in a specific configuration. It's the minimum steady flight speed at which the aircraft will stall in particular configuration, such as clean takeoff or landing configuration. It represents the lowest speed at which the wings can produce enough lift for controlled flight under those exact conditions. VSL varies with flap setting, landing gear position, weight, and load factor. It is determined during certification testing and is used to establish other reference speeds. It is not directly marked as VSL on the airspeed indicator, but related stall speeds are shown by the lower limits of the colored arcs. VX, speed for best angle of climb. It's the airspeed at which an aircraft gains the most altitude per unit of horizontal distance during a climb. It is used to clear obstacles near the runway shortly after takeoff. Flying at VX maximizes vertical gain over a short distance but results in a slower climb rate. VX is not marked on the airspeed indicator. Pilots reference it from the aircraft performance charts, which vary with weight and configuration. And finally, the last one, VY, speed for best rate of climb. It's the airspeed at which an aircraft gains the most altitude in the shortest time. It provides the maximum climb efficiency, helping the aircraft reach cruising altitude quickly. VY is typically higher than VX and depends on weight, configuration, and atmospheric conditions. Like VX, it is not marked on the airspeed indicator. Pilots use performance charts or the aircraft's operating handbook to determine the correct VY for a given takeoff or climb. This ends the 8th episode of the Canadian Aviator. Now let's go through a few questions presented on this video. These are questions that could be asked by your instructor, by Transport Canada on the written exam, or by the flight examiner during your practical test. Question 1. Color-coded markings are used on the airspeed indicator to indicate safe operating ranges and operating limits. What does the top end of the white arc read on the airspeed indicator? A. VFE. B. 110 knots. C. VSO. Or D. VX. That's right, A is the correct answer, VFE. Question number 2. What is the maneuvering speed VA? A. The recommended speed for aerobatic maneuvers. B. The maximum speed for normal operations. C. The recommended speed for normal cruise. Or D. The speed below which full flight control deflection will not cause structural damage to the aircraft. That's right. D is the correct answer, the speed below which full flight control deflection will not cause structural damage to the aircraft. Question 3. Last question. As an aircraft climbs, what happens to the best angle of climb airspeed, Vx? A. It increases. B. It stays the same. C. It decreases. Or D. It increases significantly. That's right, C is the correct answer. It decreases. If you found value in this video, a like and subscribe really help the channel. For now, thanks for watching, fly safe, and see you next time.